welcome everyone again. Welcome back to the WWCode Python track, the beginner Python study group series. We are on session 4 today, and if you just come in, you can grab the material from the GitHub repo. And just remember your chat, set your chat to all panelists and attendees so everybody can see your share, your thoughts. So and the happier the merrier. The more the merrier. So everyone will be muted throughout the webinar. So make sure everybody can hear Rishika well, and remember to leave your question on the Q&A button, Q&A section instead of the chat, because sometimes it will go it just get flooded a little and then we couldn't see. So if you have any questions, feel free to check with me, feel free to check with the team. We are all supporting you guys here today. Next slide, right, please.
And there was a question in the chat to post the GitHub link, so I just dropped that in the chat. You can find both the slides and the Colab notebook that we'll be using a bit later from that link.
Okay. Okay. So, so in case this is the first time you're joining us, I will be just quickly introduce myself. My name is Karen. I'm one of the hosts for the study group.
And I'm Rishika, and I've been co-leading, co-hosting these events with Karen. It's been a pleasure working with both Karen and Stephanie in this series, and I'm a lead for this track specifically. Stephanie is on the call, but she's unable to join with proper connection because there was actually a storm, and so she's facing some connectivity issues, but she's here to support us, and she's our cheerleader, and she's an evangelist for Women Who Code Python.
Okay, so Women Who Code, our mission is to inspire women to excel in technology careers. So our vision is we wanted to have a world where women are represented as technical executives, founders, venture capitals, board members, and software engineers. Our target is to have engineers who with two or more years of experience looking for support and resources to strengthen their influence and level up in their careers. We do take our code of conduct very seriously. We do not tolerate any harassment, any verbal harassments on our events. So if you want to check out the code of conduct, feel free to do so. Just a brief statistics for us. So we have over members over 20 countries and 70 networks. Right now, we've been host over 10K events. We raise roughly $1,000 on daily conference tickets. We offer over 2 million scholarships to partners, and we also provide access to jobs and resources, and also infinite connections for women who connect and learn and study. For our movement, as the world changes dramatically, we can be a connecting force that creates a sense of belonging while the world is being asked to isolate. So if you're just joining us, we do have for the Python track, we do have other amazing events. So if you go to the WWCode website /Python, you feel free to check it out. If it's something interested you, we encourage you to register as soon as possible. Also, please connect us with Women Who Code Python. You can check out on Instagram, Twitter, LinkedIn. We also use Slack to communicate as well. So feel free to check us out. So I'll right now I will pass to Rishika. Rishika will be the presenter today. So I will be passing the mic to her to talk about today's session.
All right, thanks, Karen. So welcome everyone again. So this is our agenda for today. We're gonna start off with a recap of session 3, which was data types in Python part 1. Today is data types in Python part 2. So today we'll be going over Boolean, set, and dictionary. Then we'll get into some live coding using the Google Colab notebook, and then some wrap up. So let's do some recap. So this is where you can find the recording, and here are the slides and the code. At this link will be posted all the slides and code for all the previous sessions and any of the future sessions for this series as well. So in the previous session, we went over 2 different types of data types. We had numeric types, which were integer or int and float. And then we had sequence types, which is string or str, and then list and tuple. So just to break this down a little bit more, between numeric and sequence, you can see that we have 2 different types. We have immutable and mutable. And this is a very important distinction to understand. So mutable means that whatever is making up that value, so whatever are the components of some sort of variable, you can actually change those. So you can delete components, you can add components. So that's where we have list, dictionary, and set. And then for immutable, where you cannot change anything. So once you already have declared a variable of that data type, you cannot delete or add any components. So that's where we have our numbers, strings, and tuples. So we went over strings, tuples, and lists already last session. Today we'll be going over dictionary and set, which are both of the mutable data type. And here's just a little bit further breakdown. Here we're comparing integer versus float, which are the 2 different numeric data types. So if we look at this table, we can see that integers do contain positive or negative values, as well as floats. However, when it comes to fractions or decimals, integers do not contain either of these, but floats do. So a really easy distinction between these 2 is that if you have anything that has a decimal point, or if it can be expressed with something with a decimal point, which is a fraction, then that is a float. If it cannot be, then we have an integer. And then looking at sequence data types, here we have strings versus lists. So a string, just a reminder, is a collection of 1 or more characters that is put in either single, double, or triple quotes. So you can put it in any kind of configuration of 1, 2, or 3 sets of quotes, and it will always be declared as a string. So a simple example of that is, hi, my name is Rishika. So as you can see, we have this enclosed in a pair of quotes. Next, we have lists, which is a collection of data that can contain different data types, like integers, strings, or objects. And so a very nice example here, we have this list, and this is basically declaring the variable here, and then we set that equal to this list. And the way we declare a list is using these square brackets. So here we have Python, Java, C++, and these are all the 3 different values that make up this list. And then we have tuple, where it's the same function as a list, except for a tuple, we cannot edit it in any way after it's already been created. So that's, again, immutable versus immutable. So a list is mutable, but a tuple is immutable. So for declaring a tuple, we have it declared in a very similar way, just by naming a variable. But here we declared with a set of parentheses, whereas for a list, we declared it with a set of brackets. So that's another very important distinction. So given that, we're now going to switch over to our next 3 data types for today. The first one is Boolean. So Boolean kind of encapsulates this meaning of truth or falsehood. So basically you have 2 possible values, true or false, which is something that we're pretty familiar with. So that's a very nice way to sort of think about it. We just have these 2 different possible values for any sort of Boolean data type. And the output of this is class bool. So if we want to check the data type of a certain value, as we have done in the previous session, and we'll be doing that again today, a simple thing is to just check the class, and we kind of get the confirmation of what data type it is. And in this case, what we expect for the output is class bool. And as I mentioned, true or false are the 2 main possible values. And but these keywords must be in uppercase. If they're in lowercase, they'll actually be recognized as a variable, and Python will not recognize this as actually the output to any sort of Boolean operation that we have. Also, integers and floating point numbers can be converted to Boolean. We'll be demonstrating that a bit later on when we do some live coding. And lastly, we have some arithmetic that we can do with Booleans. And this is where we have operators. And these operators, just to list a few, we have and, or, not. And then to declare equals or not equals, we actually have to put 2 equal signs. Because as you know, when you have just 1 equal sign, that's used to basically set a variable equal to a value. So as you saw when we were declaring the list, we basically had this list equal to, and then we declared the list. But in order to differentiate between declaring the variable and actually this Boolean operator, we actually have to have 2 equal signs. So for, and I'll be showing this again with some code later on just to sort of reinforce the knowledge, but basically, if you want to find out if 2 values are equal to each other, we do a double equal sign, and if they're not equal, we do an exclamation point in front of it, and then an equal sign, so basically not equal. And then as for and or, that's where we kind of get into some sort of like thinking about logic in a sense. So if you were to sort of put 2 different conditions together, and we want to see if for and, we actually are considering both of these conditions have to be true or both of them have to be false. But when it comes to or, to satisfy the condition for either true or false, only one of them actually has to satisfy. And again, this will kind of be a little bit more clear when we actually get into the coding, but just to sort of get you thinking about this. Next, we have a set. So a set is an unordered collection that is iterable and mutable. So just as a reminder, mutable means that we can sort of pull in and push out different elements that we have already declared to be part of the set, just like we have for a list. Another important distinction is that it can have no duplicate elements, meaning everything that is in there is a unique value. Also, the order of elements is undefined through various mixed up data types. Data type values can actually be passed to the set. And a set is created by using the built-in set function. As you saw with both list and tuple, we do this very easily with Python. That's how we can declare a set basically. And we can do that with either an iterable object or a sequence by placing the sequence inside curly braces separated by commas. So just the same way how we declared a list in a tuple with a different value separated by commas, but in this case we have curly braces. Lastly, items cannot be accessed by referring to an index, and that's because items that has that's because items actually have no index because sets are completely unordered. So there's no sort of set position that every value is assigned to. Therefore, you cannot access them by that position. But a way to actually access it is through looping all of the items in the set. And this is using a for loop, which we'll actually go over in the next session. So I'm not going to touch on that too much, but that's one way that you kind of can access different items in the set. Or you can also ask if a specified value is actually present in a set, and you can do that by using the in keyword. And we will actually be doing that later in the live coding, just because I want to demonstrate how you can actually access an element and how you can't just refer to any value by its index. And then the last data type we have is dictionaries. So a dictionary is an unordered collection of data values, and it tends to store values like a map. That's one way to think about it. And it can hold a single value as an element. So just like how we had a set declared within the curly braces, the same way we also declare a dictionary, again separated by a comma. But here we actually have these key value pairs. So a key is provided to make it more optimized. A key element cannot be repeated, and it must be immutable. And it's also case sensitive, meaning that if it's uppercase or lowercase, it does make a difference. And then associated with a key is the value. And the value is basically the corresponding pair element, which can be of any data type, and it can be duplicated. So therefore, one key can only be assigned, there can only be one I guess, unique key for every dictionary, but you can have, the values do not have to be unique. So that's another very important thing to keep in mind. There are multiple ways to add elements. We'll be showing you a few different ways that you can add an element to a dictionary. The way you can access an element is basically referring to its key name, because that's kind of the associated value to the associated element to the value. Or you can also use the get method. And lastly, you can also remove an element by either doing the del function or the pop function. And we'll be demonstrating this in the live coding as well. All right, so that is everything for the slides. And so now we're gonna jump over to the Colab notebook. Hopefully everyone has that up and running. I'll make sure to show how to access how to open the GitHub from the GitHub link, how to open it into Google Colab, so we kind of have that whole process. So I'm just going to switch gears here, and let me just navigate to the GitHub link. So when you click on that link, it'll take you here, and then you can just scroll on down to Women Who Code Python. And this is basically everything that all the previous series that we have and ongoing series as well. And if you just scroll on down a bit, you will see our series is right here, Beginner Python Study Group. So just click on that. And then scroll on down, and today is session 4. So we'll be accessing the Colab notebook. So let's just click on that. And once you click on that, then it'll take you here. So hopefully everyone has been able to get to this step. Please let us know in the Q&A if you're having any issues. But if you are able to access a notebook and get here, please put a thumbs up in the chat. You can do that by just putting a lowercase b. So just like this, how I put it in the chat. Okay, perfect. I see a ton of thumbs up, so I think we're good to go. All right, wonderful. And all right, so let's get into this. So from the last session, we actually did, okay, I think someone says, can you show one step back, please? Yes, of course. So let me navigate back to the GitHub link. Sorry, just give me a second to pull it up. Okay, so this is a link, and then these are all basically the different chapters for Women Who Code. If you scroll down to Women Who Code Python, what I can do is actually just give you this direct link here, so you have that. And basically when you click on that, it'll take you here, and then scroll down, and you want to find Beginner Python Study Group. And there, these are all of our resources, all of our session materials from the previous sessions with the slides and the Colab notebook. And today is session 4, and we want to access the Colab notebook. So if you click on that, it'll take you directly here. So hopefully everyone is able to get here now. Okay, wonderful. All right, happy to help. Okay, so tuples was part of the last session, but we weren't able to quite finish all of the coding. So I'm gonna sort of take a couple steps back, and we're gonna get back into the coding again. So creating a tuple. So what we'll be doing is we'll begin by creating an empty tuple. So we're going to name this tuple 1. Make sure to have a capital T in that. And it will be empty to begin with. So the way we do that is basically tuple 1 is equal to, and then just put a set of parentheses. And then from there, we want to basically print out tuple 1. And then just as a reminder, to run any code, you can press the play button, or you can also, if you hover over here, you can see that you can press Command Enter if you're on a Mac, or Control Enter if you're on a Windows. And thanks for the reminder, Karen. Yes, please remember to click File and then Save Copy on Drive so that you can actually have your work saved. The worst thing is to lose your work. So thank you for that reminder, Karen. So let's run that and you'll see that the output is just the parentheses. It's completely blank because we did not add anything to the tuple. It's completely empty. So that's the output that we expect. So next, we will create a tuple with the use of strings, just like we did for lists earlier in the last session. So this will also be called tuple1, and it's going to contain the values women and who. And then we're going to print out the value of tuple1. So just the same way how we had tuple1, and we're going to have a set of parentheses because that's how we declare a tuple. And then we're going to have the value women as a first element, and then the value who as a second element. And again, we just want to print out tuple1. Let's run that. And as expected, now we have in these parentheses with the first value as women and the second value as who. And so from there, we're going to now create a tuple with the use of a list. So I'm basically just creating a tuple with a few different ways just to show you for not just for tuples, but for all data types. There's a lot of different ways to declare it, and it just shows how much you can actually do with Python, which is really amazing. So now we'll create a tuple with the use of a list, and we're going to name this list1, and will contain these values 1, 2, 4, 5, 6. So I'm actually just going to highlight over these and just copy them so I don't have to retype them. And then what we're going to do here is basically have list1 is equal to, and again, remember for lists, we have declared with these brackets. And then we can basically just paste these values in here. And then let's just print out, I'm going to print, and then we basically want to call the built-in tuple function and call it on our list. So we're basically converting this list that we've already declared into a tuple. So we just do tuple list1. And if we run that, then we should expect, oh, I spelled that wrong. And we should expect 1, 2, 4, 5, 6. And now we have the confirmation that it is a tuple because we have it in a set of parentheses. So that is a tuple, creating a tuple with the use of a list. Now we will create a tuple with the use of the built-in function. Again, this is going to be called tuple1, and it will contain the value women who code, and then we're going to print it out just as confirmation. So let's do tuple1 is equal to, and then we're basically going to call tuple. So this is a built-in function. And what's nice about Colab is actually, once you start typing this out, it'll kind of show you what Python expects. So if you see here arguments, that's basically sort of what the tuple function can take in as a value. When we have a tuple just declared as that, it's a completely empty tuple, which is what we did in our first step. And then we can also put in another iterable in there. We're not going to get into that today, but that's basically just showing you some information about what this built-in function can do. So what we're going to put in here is women who code. So let's just hover over that and copy that. And we have to put it in a set of commas, sorry, instead of apostrophes. And then let's print tuple1. And so what should we expect is basically now it's sort of taken this and broken it down into individual values. And so now we're able to create a tuple where basically it took this one single string and broke it down into several individual elements. And let me just check in. Okay, it's going a bit fast. Okay, I'll slow down a little bit. And so the KW args, that's basically like the, we won't be doing that right now because it's a bit more advanced for our beginner. Basically, it's keyword arguments. That's what KW args stands for. And then, all right. So I'm going to, there's one more question in the Q&A, but I'm just going to continue on. I'll break for another round of questions in just a little bit. So we just created a tuple with the use of the built-in function, and now we're going to create a tuple with nested tuples. So what we're going to do is going to start out with tuple1, which is going to contain the values 0, 1, 2, and 3. Then we're going to have tuple 2, which is going to contain the values Python and women. And then finally, we'll have our tuple 3, which is going to contain the values from tuple 1 and tuple 2, which we have already declared. And then we're going to print this out just like we have been, just to get a confirmation that we did what we wanted to do. So let's start here. So what we're going to do first is have tuple 1 and then set that equal to, and I'm just going to copy and paste that. I've learned that that's a nice thing to do, is copy and paste, because you do get to save some time. And then tuple 2, we're basically just going to take these values and put them in here, but make sure to enclose them in quotes. Otherwise, it will give you an error. So we have that. And then we're going to have tuple 3. And now we're basically just going to combine both tuple 1 and tuple 2 into this tuple 3 value to get a nested tuple. And then we're going to print this out just to make sure that we did that correctly. And tuple 1 is, let's see, what did I do wrong here? Did I have an indent somewhere? Oh, yeah, okay. My mistake. All right, so now you can see that we actually have a nested tuple, where basically we have these two sort of sub tuples inside a bigger tuple, is one way to think about it. And we basically now have one single tuple that basically contains two other tuples that we already declared.
Sorry, Rishika, do you mind increase the size, like kind of increase the size of the screen?
Yeah, definitely. And is that better?
Is it better, everybody? Let us know. And also, before you go to the access element, could you quickly go back to the creating a tuple with use of lists?
Yes.
Real quick. Thank you.
Okay. Yeah, of course. Thanks for letting me know. Yeah, so another way to create a tuple is with the use of a list. So again, we're going to name this list 1, and the way we declare lists is with the set of square brackets, and it's going to contain the values 1, 2, 4, 5, 6. And then basically we're going to call tuple on this list 1 that we have already declared. And basically what Python sees is, okay, now we have this list and we have called the tuple function, this built-in tuple function on it. So it's basically just going to convert the list to a tuple. And we get that confirmation by seeing that our output does have a set of parentheses, and that's our confirmation that it is a tuple. So hopefully that clears any questions about that step. And let me jump back to where we were. So the next thing is accessing an element from a tuple. So let me just, okay. So now we'll be accessing elements from the tuple. And again, this tuple will be called tuple 1 and will contain the values 1, 2, 3, 4, 5. So let's do tuple 1 is equal to tuple. And we're gonna have 1, 2, 3, 4, 5. And then we're gonna basically just print that out. And, oh, sorry, my bad, print tuple 1. So now we have our tuple here with 1, 2, 3, 4, 5. Next, we're going to access an element using indexing. So indexing is basically a way to print out a certain value or access a value based upon its position in some sort of list, sequence, dictionary, whatever it might be. So the way we do that is we're actually going to print, and then taking tuple 1, the way that we index is by using square brackets. So these square brackets right here, and then we want to access the first value. And the way that positions work is that we actually start at 0. So the first value in any sort of sequence or string, whatever it might be, is actually at position 0. And then we go 1, 2, 3, 4, 5, etc. So that's a very important thing to keep in mind. So if you want to access the first value, you actually have to put 0 here and not 1. If you put 1, it's actually going to access the second value. So let's print that out. And as you can see, it prints out 1, and that's correct because that is the first value of our tuple. So from there, we're going to, okay, so I access that, and then we're going to access an element using negative indexing. So negative indexing comes in handy when we have, say, a very long list of elements or a long tuple of elements, and say we want to access the last one, but maybe we don't want to go through all of it and get to the end. There's a really nice and easy way to sort of just go, instead of starting from the beginning and going all the way to the end, we can basically start at the end and then go from there. So we're going to access the last element of tuple 1 and print that out. So the way we do that is, again, with tuple and then using the square brackets, we're actually going to do -1. And that will print out the last element. And then what we're going to do here is, let me actually put a print statement in front of here so that we can actually print it out. And then for the third to last element, we're actually going to have to put in -3, because if we think the last element is -1, the third to last is -1, -2, -3. So we actually have to put -3. Okay, my bad. I think I'll leave the previous cell visible. Hopefully that helps out. Just put a thumbs up if you can see the previous cell properly. And okay, so again, we're going to have tuple -3 because we want to access the third to last element. So we do -3 and then print that out. And as you can see, what we get is, what happened here? Oh, tuple 1. My mistake. I did not put that properly. Okay. So now we can see that our last element is 5. That is correct. And our third to last element is 3. So we have 1, 2, 3. So that's perfect. Another way we could have accessed the value of 3, since it's right in the middle, is we could have done -3, or we could also have done 2, because if you see, this is position 0, position 1, position 2. We have a small enough tuple here, so it's not too hard to just use the normal indexing. We don't have to use negative indexing, but I still wanted to show you that that does come in handy sometimes. All right, so that's it for tuple. Before I jump into Boolean set and dictionary, I'm just going to check and see if anyone has any questions. So I see, how can I check elements order after looping the list a couple times? How can I check elements? I'm a bit confused about the question. So if you have looped the list a couple times and you want to check the order, I guess the order of the elements would really only change if you have removed anything or added anything. So checking the order, again, you could just print out the entire list and then they can show you the order of the elements. I hope that clarifies your question, but I'm not too sure. And then tuple is like an array. I guess somewhat, but arrays come in pretty handy when you have like multiple dimensions of values. So we won't be going over arrays as a data type, but one very popular way of thinking of like a two-dimensional array is like a table where you have, you know, a set of rows and columns that sort of correspond to each other. So I guess a tuple is similar to a one-dimensional array, but arrays definitely have a lot more capabilities than just a tuple. And then let's see. It'd be helpful to mention a real world example of when we would actually use the tuple function to better understand the definition. Yeah, so as I mentioned in the, let me actually just bring this up back in the slides. So if we look here, tuples are immutable versus mutable data types are lists. And lists and tuples are very, very similar, except with tuples, you can't actually modify any values. So if you were to have some sort of use case of where you have some series of elements declared, but you don't want it to be changed in any way, like in order to change it, you would have to copy it and then, you know, set it equal to a new variable and then change things about it. But if you had a use case where you wanted to make sure that that data was contained and was retained in some way, that's where you'd want to use a tuple. I guess that's one example where you would want to use a tuple versus just a simple list. I would say lists in general are a lot more common because they are mutable. There's a lot more use cases in the real world where you do want to have sort of a sequence of elements where you can change things, where you can remove elements and add elements. So in general, even in my classes and in my experience, I've definitely used lists a lot more than tuples. Okay.
Quick things, Rishika. They like some attendees that they can really see, they still see the code a bit small. I just wanna quick check with everybody is like I see like as my from my screen I see Rishika's screen relatively clearly, but I want to make sure you guys are all good. So give us a thumbs up if everything is good. Okay, awesome, guys. Okay, sorry. Thanks, Rishika.
Okay. Yeah, no worries. Okay. All right, so let me go back down to Boolean. So let me actually just check the Q&A, make sure everything's good. Okay. All right. So as I mentioned, a Boolean type returns either true or false. And to check if a variable is of the Boolean class, it should return class Boolean. When you, for example, when you type A, if A were to be a variable that you've declared to be a Boolean. And here are some operators that we can use for Booleans. We have or and not, which are more you know, conditional operators. Then we have two equal signs, which means equivalent. We have an exclamation point and then an equal sign, which is basically not equal or not equivalent. And then we have greater or greater than or equal to, and then less than or less than or equal to. So let's start out with something simple. So how do we find out if 10 is greater than 5? So we can use one of these operators right here. And since we're looking at greater than and not greater than or equal to, what we can do is basically do 10 greater than 5. And if you run that cell, we would expect the output to be true. It's taking a little bit of time. Okay, so it's true. That's what we expect because as we know, 10 is a greater value than 5. Let's do another comparison. Let's compare two numeric values. We have 3.1 for all of that, and then all of this. So just to save you guys some time, what we can do is basically copy these over. So I'm going to first copy that one. We're going to declare this one as pi1 is equal to that. And then we're going to have pi2 is equal to this second value here. All right, and then now we have pi1 and pi2 declared. And now what you want to do is actually compare these two. So what we can do is sort of like a guess before we actually compare it. So if you look through all of these digits here, we can see that there is one difference right here. There's a 3 and here's a 9 here. So we expect that if we were to call pi1 equal to pi2, we would expect that to be false. But just to mix things up, let's actually do not equals to. So let's do pi1 and then exclamation point equal sign pi2, and we would expect that to be true. And that's because pi1 and pi2 are indeed not equal to each other. And then let's actually compare some strings. So we're going to declare the first string as this right here. Let me just copy that. And then we're going to have the second string as this one right here. And we're going to do the same thing. Let's do a little guess of our own in advance. So let's we scan along here, we can see that there is a difference here. So if we were to say A equal to B, we would expect that to be false. So this is working as we expected. Now let's make things a little bit more complicated. Now we're going to actually be using some lists. So we're going to make a list of ingredients for dinner. So let's do chicken. Let's do onion. I'm going to do some carrots. Let's get some vegetables in for dinner. Let's do cherry tomato. And let's also do some broccoli. All right, so we have our dinner list set. And now what we'll be doing is actually finding out if onion is in the dinner list. So this was actually something that I mentioned where we can use the in keyword to basically see if a certain value is actually an element in that sequence. So what we're going to do is using the print function, we're going to say onion, make sure to put this in quotes, in, and then dinner is the name of our list that we've already declared. We're going to do the same thing and print out for tomato, and we're going to see if tomato is in our dinner. So let's do tomato in dinner. All right. So before we run this, let's try to guess what the value should be. So if you look at onion, we can see that that is declared in our dinner list. So we expect that value to be true. And then for tomato, we can see that we have tomato here, but there's actually cherry tomato. So those are not the same, so we'd expect the second one to actually be false. So let's run that, and as we expected, we have true and then false. And then let's do some math here. So we're going to find out if this formula on the left here is greater than this formula on the right. So what we're going to do is basically I'm going to highlight this and copy that over. And then since we're doing greater than, we can just use the greater than sign. And then we're basically going to take all of this and copy it over here. And I actually did the math earlier, and so the value should be true, and that's the value of true. I'm not going to do all the math right now, but that is confirmed. So we can say that this formula on the left here is greater than the formula here on the right. And then one last thing for Booleans, we're actually going to make it a little bit more complicated, make the list a little bit longer, and we're actually going to have two lists declared. So the first one is going to be called favorite egg types list. And so we have scrambled, omelets, over easy, sunny side up, over easy, over medium, omelets. And then we're going to have okay egg types list. And we're going to have poached, boiled, baked, over hard, or over medium. And so the first thing we're going to do is check if sunny side up is in either of the egg lists. So remember, we're actually going to use these operators from earlier. So we're going to be using or and. So if we were to think of conditions in sort of another sense, is that for or, it only has to satisfy either this one or this one. But then for if it needs to be in both lists, it actually has to satisfy both of them, and that's why we use the and operator. So what we're going to do here is we're going to print, and since we're checking sunny side up, what we can do is basically take the sunny side up value, put that in here, and then we're going to use the in keyword, and we're going to basically do favorite egg. And what a nice thing that a lot of development environments do is it kind of suggests the word that you're trying to type out, so you kind of save a little bit of time. So let's just click on that. And then we're going to just do sunny side up in favorite egg types list or okay egg types list. Since we're checking in either of the lists, we're checking in either of the egg lists. We're not doing that it has to be in both. That's actually the next one that we're doing. So for the next one we're going to do is we're checking if over hard is in both. So let's just take that value, put it in here. And then we're going to see if it's in favorite egg types list and okay egg types list. So here we're using the and operator because we need to make sure that it's in both of the lists. So let's print that out. And as you can see, we have true and then false. So let's see if that's if Python is actually right. So sunny side up in favorite egg types list or okay egg types list. As you can see, sunny side up is in favorite egg types list. So it satisfies at least one of the two conditions. So it should be true. For the second one, now we want to see if over hard is in both of the lists. So over hard, as we can see, is in the second list, but we don't see it in the first list. So that's why we get false, because it's only there for one of the lists. If we had tried to print out over hard in favorite egg types list or okay egg types list, that would have been true. But using the and operator, that is false. So that concludes everything for Boolean. I'm just going to have a friendly reminder here for where we use quotes and where we don't use quotes. So if we were to have a string like this with apple or 145, as you can see, it's enclosed in quotes. So if you have words or any sort of letters or numbers with quotations, that will be a string. On the flip side, we also can have the same word apple, but we don't enclose it in quotes. So in this case, when there's no quotations, it actually recognizes it as a variable. So just like we had favorite egg types list, just on its own without any quotes, that's basically Python recognizes it that it's a variable. And then lastly, if we have any numbers without any sort of quotations, that's an integer, for example, 32. But if we were to have, say, 32.5, that would be a float. But either way, it's a numeric data type. All right, so next we have sets. I'm just checking in the Q&A. Yes, to save, what you do is you go to File, and then you do Save a Copy in Drive. And that'll basically make sure that a copy of this is saved in your Google Drive and that you don't lose any of the work that you've done. All right, so for sets, let's see, is there a separate function that we could use to determine the exact list to find sunny side up? Use to determine, let's see, separate function. Yeah, so I mean, what you could do is just directly print out sunny side up in favorite egg types list, just that on its own, and that would give you true. But are you, I guess, is the question like we would want the output to actually say favorite egg types list and not just true or false?
Just to add up on the question from Eliza's question, I believe it goes one way only. So we can extract the elements from two lists. However, it's a bit hard to actually track down which list the one is from. Especially it's a common, like, because you're putting like so many like you're giving like a very broad condition. So for it's a bit go to harder. So sometimes like we do want to narrow down like one like eight we know it on the list first, and then we start increasing the conditions like from there. So yeah, it's a one way only tracking, not like going back to find out which list.
Yeah,
hope it helps.
Thanks, Karen. Okay. All right. Okay. And then for set, so just as a reminder, sets are a collection of strings or integers with no specific index or order. So in this sense, it's kind of similar to a list, and it helps to automatically sort the values in alphabetical order. And here are some possible things that we can find out for sets. So we have LEN, which stands for length. So basically it finds out the number of elements in a set. We can also use this in keyword again to basically see if X is actually a member of the set S. On the flip side, we can also do X not an S, so basically seeing if X is not part of the set. And then here we have some more advanced functions that we can do with sets. So here we have a subset. So basically seeing if we have two different sets, S and T, if we do S dot is subset T, or essentially is S less than or equal to T, that is basically testing whether every element that is in S is in T. So basically, is S a subset of T? And then S is a superset of T, meaning that S is greater than or equal to T. That is basically seeing whether every element that is in T is also in S. Then we also have union intersection. So union, if we're thinking again about sets S and T, we can see that if we do S dot union T, then we're actually declaring an entirely new set with elements of both S and T. But then if we do S dot intersection T, this is again declaring a new set, but it's actually only grabbing the elements that are common to both S and T. So it's not looking at, it's not grabbing all of the elements from S and T, just picking all of them up. It's just looking at what is actually common between them. So if S and T have no elements in common, and we call this, then this new set is going to be completely empty. Then we have S dot difference T, and here we actually, it's kind of doing S minus T. And this is again declaring a new set with elements that are in S, but they're not in T. Then we also have a symmetric difference where we have a new set that have elements in either S or T, but not both. And then S dot copy is basically we're declaring a new set, but we have a shallow copy of S. So basically just only grabbing the values. So we won't be using all of these, but it's nice to just have it all listed here so you can see what all things that we can actually do with sets. So here what we're going to do is actually obtain the unique values from our favorite egg types list. Since we already had that declared, we do not have to list out those values again. So what we're going to do is actually print, and then we're going to call the built-in set function, and then we're going to have our favorite egg types list. And because, as I mentioned, sets only look at the unique values, since we're just calling set on this list that we already have declared, is basically only going to print out the unique values. Therefore, if we were to have, say, sunny side up twice in there, when we convert it to a set, it's only going to have one value of sunny side up. And then now we're going to print out the original favorite egg types list just to compare, just to see what is the difference. So as you can see here, we have the original list had scrambled, omelets, over easy, sunny side up, over easy, over medium, omelets. And as you can see, we have two values less, and that's because omelets was repeated twice and over easy was repeated twice. So now we only have one value of each of them. We only have one over easy and we only have one omelets. So that's what's actually really valuable about sets, is that it only looks at unique values. So now what we're going to do is find out the type of egg that shows up in both the favorite egg type and the OK egg type. So basically, what egg shows up in both lists. So the way we do that is basically we're going to call set, and then we're going to first do our favorite egg types list, since that's the first list we're looking at. And we're going to use our intersection method here. And then we're going to call, again, set on OK egg types list, since we want to convert both of these to sets. So if we were to run that, we'll see that, oh, did I spell something wrong? Set, oh, right here, my bad. I need to add a parentheses right here. Okay. Let me actually, some extra parentheses there. Okay, there you go. So the output we have here is over medium. So let's see if that makes sense. So what we want to do is actually see what egg is showing up in both lists. So if we look up here, we can see that in both of these lists, over medium is the only thing that exists in both lists. And as you can see, it's here and it's here. So that's correct. So we get that confirmation. Let me just check in with any questions. Can we check if an element is in a tuple within, so we can check if an element is in a tuple within, but can we get its position? I I don't believe we can get its exact position. We can only check if it's a member of the tuple. Karen, do you agree?
That's from my understanding as well. Yes.
Mm-hmm. Okay, yeah. So we can only check membership with that in keyword, but from that we can't go any further and actually get its exact position. Okay, so I don't see any more questions, so I'm going to continue to our last little bit of coding, which will be for dictionaries. So like the word dictionary, as it implies, this sequence data type stores values in an unordered manner. Dictionaries in Python consist of two main elements. We have those key value pairs that I mentioned. And the way to declare and represent a dictionary is using curly braces. Here's just a simple example of a dictionary. So say we have dairy is the name of our dictionary. And then inside this, we enclose everything in these curly braces right here. And then the values that you see to the left of this colon are the keys. The values to the right of the colon are all of our values. So that's how you see these key value pairs. So in this dictionary, we actually have two keys, and we have 1, 2, 3, 4, 5 values for that key, and 4 values for the second key. So let's get to this last bit of coding. So what we're going to do is create a dictionary that consists of 3 key value pairs of items, and then we're going to give it an appropriate variable name. So let's give it a name called series of nums, because we're actually going to declare this dictionary to have a series of numbers. It really helps to appropriately name your variables, as it's a very common coding practice, so that not only you can understand your code better, but if someone else were to look at your code and try to understand it, they would be able to make sense of it. So that's an important thing to keep in mind. So let's declare our first key. That's going to be 1, and then the corresponding value is going to be 1.25. And then we're going to have our second key, which is going to be 2, and then the corresponding value is going to be 0.06. And then our third key will be 3, and then we're going to have the value 2.73. And I see a question about how do we know that I have 3 keys. So that's just something that that we're kind of going in mind going into this. So we want to create a dictionary that's going to have these 3 key value pairs. And the way we know that is because we have these 3 colons, which correspond to our 3 key value pairs. And then let's just print that out just to make sure that that was declared properly. And we print that out, and oh, my bad. I don't know how that parenthesis got in there. And as you can see, now we have our dictionary declared. It's enclosed in these curly braces, and we have 3 key value pairs inside of it. So now we're going to append an item on the second series of values. So what we're going to do is series of nums. We're going to say 2, and then we're going to basically add in 6.31. And then we're basically going to call this again, series of nums, just to make sure that we actually did that properly. And as you can see, the way that we specify for the second one is basically with this value of 2. And now you can see that basically now for the second key, we now have 6.31 there as our value. So let's say that we added this value, but that actually wasn't the correct value that we wanted to add. So say that we want to delete it. So one of the ways that we can delete any sort of value is using .pop. So let's do that. So let's say we have series of nums. Let's call that dictionary again. And then we're going to just do .pop. And then inside there, we actually have to specify first the key and then the corresponding value. And then let's print that out again. And as you can see, now we only have the first key value pair and the third key value pair. And now the second one is completely gone since we deleted it. So that worked as we wanted it to. And lastly, now let's say that we decided that we don't want the third set of the values, so we want to delete it. Another way to delete it is actually just calling del. And then we're going to say series of nums. And let's specify the third key value pair by using the number 3. And then let's print that out again. And we can see that now we only had the first key value pair, so we were able to successfully delete the third value. So just as a reminder, this shows that dictionary is a mutable data type, which are definitely have a lot more use cases, and they're a lot more they're a lot easier to work with than the immutable data types, just like tuples. Okay, so that's it for our live coding. Here's just a link down here that shows some common functions that can be used. It does include some of the ones that we went over today, along with a few more that we didn't include in today's session, but feel free to click on this link and see what else we can do with dictionaries. So let me go back to the slides. All right, so just for some wrap up, today the Python data types that we covered were Boolean, set, and dictionary. Today was the second part of that. Next session, we'll be focusing on programming logic, specifically flow control, and going into a little bit more of sort of understanding how we can work with if statements, else statements, for loops, and while loops. All of that will start to make a little bit more sense when we get into it in 2 weeks. And so we're gonna stop for some more questions right now. If you're not able to think of any questions right now, if something were to come up later, please join our Slack channel. First, join our Slack community if you haven't already, and our specific channel for this series is Beginner Python Study Group. So let me see what questions we have. All right. So I see, why is there an underscore at the beginning of the variable name? That's just just how I decided to declare it. We can include underscores in variable names. We are allowed to do that in Python. I just chose to do that, but you know, it's not necessary in any way. Let's see. Okay, can we compare dictionary to JSON or object like we have in JavaScript? I guess a dictionary is similar to how we have value sort of stored in a JSON file, but I would say that the amount of things that you can do with how values are stored in JSON files are a lot more advanced, and that's where you kind of get into more sophisticated and more advanced sort of data flattening, data pre-processing, and all of that. But there is definitely some translation between those two. Let's see. So can keys have more than one element? They can. So as I showed in the notebook here, when we had this dictionary right here, when we have cheese and then we have cheddar, blue, goat, etc. So you can have multiple values that are corresponding to a single key. Let's see. I see something, you don't need to say print series of nums. Yeah, so you don't actually have to put print in front of it. It does print it out if we just sort of write out that variable. Can we delete elements from the dictionary using just the key, not the key and value for the pop function? I believe yeah, so for the delete, you can do it with just the sort of the key that's corresponding to it. But for pop, I believe you do have to have the corresponding key and value in there for it to properly delete. Karen, is that, do you agree with that? Or maybe I'm misremembering.
Sorry, which question? Sorry.
If we can delete elements from the dictionary using just the key for the pop function. But I
Yes, I
believe you need the
believe
key and
so.
the value. Oh, okay. So we don't.
I think you can. I think you can delete delete the whole. If you want to delete the whole set of value from key, you can just delete by the key. Yeah, you don't have to specify the value. Yes.
Okay. Okay. Explain the use of a set in an example. So I can scroll back up here, and one really, I guess, use of a set in an example. Trying to think where sets are really important when here we kind of have like individual items in here, but say, because you can see that we have so many things with subsets and supersets and unions and intersections. So sets come in really handy if we, were to have two groups of items and say those groups were very, very large and we wanted to see just, what is common between two of them, or say we wanted to combine it into another large set. We can also do differences and symmetric differences. So there's lots of different ways that we can use sets and where we actually apply sets. I hope that kind of gives you an example or a frame of reference for sets.
All right. One thing to clarify about tuple using index tuple, Elise has thank you so much, Elise. So actually, yes. So if you want to find a value, if you find the ordered value, yes, you can do that. You can use index to do so. So I'm just gonna post Elise. I'm gonna post Elise statement again so everyone can see. So if you have a list of tuple, you wanna find function, you want to find the value, like the location of the value, you use this syntax. So basically my tuple dot index and then the specific value to find the location. Thank you so much, Elise, for that.
Thank you, thank you. Maybe we
We
can
learn a lot.
try that out. Yeah. There's no end to
Yes.
learning.
Yes.
So let's actually try that out. So I see.
Yeah.
So it's tuple.indexVal. So we have our tuple one. And then we want to find out the index of, let's say, this value. So value 2. So that should give us card.
Tuple 1.
Oh, yes. Sorry. My bad. I don't know why I'm making that mistake. Okay.
It's
Yeah, that
okay.
works. So now we have
Yes.
our 2. And as you know, this is our, even though it's our second value, it's actually corresponding to index 1 since we start out at 0. Okay, thank you. Thank you for sharing that information.
Yes.
Let's see, are there any other questions? I don't see anything in the Q&A. If you do have any questions, please drop it in the Q&A. We kind of are done with today's material and the coding. So now is the time for any last minute questions.
Meanwhile, if everyone is typing their last, the last minute question, I do want to mention a couple of things. First of all, so reminder for the personal projects that we talk about on the first or for the first section, we do create a poll and the Python beginner study group channel on Slack. So if you wanna remember to follow, if you haven't followed yet, if you want more information, please go to the channel as well. Also, we on November the 4th, we do have a review week for everyone to catch up. So I'm gonna post a Google form right now. So if you guys wanna so let us know how there's what kind of material or anything that you want to review with us, and we can explain it more. So so please figure it out and let us know whether you guys think or anything new, or even anything new that you guys work on, and maybe we can plan it on in the future section as well. And also, I just have to say, you guys have been amazing, like helping each other out. This is the first time I see the chat, but like you guys have been amazing, like troubleshooting for each other. This is like what we want to see, and like I'm really so glad to have all of you being so
Yeah.
helpful with each other throughout the section. And I mean, like you, like at the same time, you learning from me and Rishika also learning from you guys as well.
Yeah.
So thank you so much. You guys have been
Yeah. Thank you,
amazing.
everyone.
So so if you guys don't have, is any questions left? Oh, one more, Rishika.
Okay. Let's see, how to access from a certain range, for example, 0 to 3. Yes, so we can do that. Let me go back into the notebook. So let's see, let me actually, I know I can do this with a list. So here we have, okay, so if we were to say we had list 2 is equal to 0, 1, 2, 3, 4, 5, 6. And then we basically just want to print out list 2. And the way we index is with the square brackets. And then let's say if we want to go 0 to 2. So what this is doing here is 0 to 2 essentially translates to the first 2 values only. But if we were to change it up to 0 to 3, then it's actually going to go to 0, 1, 2. So we can actually do ranges. We can extend it as far as we want, as long as there's actually a value there. So if we do 0 to 4, we can see that we have 0, 1, 2, 3. So we can access elements using a range. All right.
Okay, if there's no any other questions, I think we'll end this section. The next section is 2 weeks later for the programming logic. So we hope to see you guys there. And thank you so much for joining us again.
Yeah, thank
Bye,
you, everyone. And
guys.
I hope everyone enjoyed the session.
Yes. Yes.
All right.
Yes.
Okay.